Question 4, we have geometry. We're given this triangle ABC and we're told the point A is 4, 2. You can see that on the diagram. We're asked to write down the coordinates of B and C. So you can see B here, 8 out, 8 on the x-axis, up 0. And C is out 10 and up 4. Should be a visual thing for you. We're going to be looking at the length of sides in these triangles. So I may do that now. You can see AB, we have 4 here, and we have 2 here. AB is going to be the square root of 2 squared plus 4 squared. Here we have a 2 and a 4. We're going to be looking at slopes too. So along this line here, BC, we also have square root 20. Now straight away that means that it's got two 45-degree angles in here and here, or even a isosceles triangle, which means that this one is a right angle. And we'll just show that again with the slopes. You can see the slopes here. I might have jumped a step ahead, but the slopes here, the product of these slopes, the slope of AB is equal to the rise over the run, 2 over 4, and you can see it's negative. And the slope of BC is positive, and it's the rise 4 over the run 2. If we multiply those two together, we're going to get -1, showing that the angle in between is 90. I should have really started with that maybe, and then gone into the 2 root 20s, but that's as much information as we can put on this triangle for now. So let's look at the next part of the question. We're told here the lines AC and AB are given below, and we're asked to find M here, so we just need the slope of AC, and we're asked to find the constant, which is given as K here in AB. So the slope of AC we don't have, it's one of the ones that we didn't get, so we can go up this way, a rise of 2 and a run from 4 to 10 of 6, a rise of 2 and a run of 6, which is an M of 1 over 3. You can check along this way too, of course it's going to be the same, a run of 6 and a rise of 2, 2 over 6, no matter which direction you go. So AC, M is equal to a third, with your knowledge of slopes. For AB, we just have to plug one of the points in that's on AB. Here's B, so plug 8, 0 in here. So when Y is equal to 0, X is equal to 8 minus a half times 8. If you want to write it out the long way, you could just write -4. So you can see here K would have to be equal to +4, bringing the -4 to the left. We're asked to show that the area of the triangle ABC is 10 square units. That's why we got the right angle at the beginning, because we read the whole question, half the base by the height. In a right angle triangle will give me the area. So we have half, we got root 20 for both the base and the height. Half root 20 by half root 20 is half 20, which is 10 square units. Then we're asked to draw A prime, B prime, C prime, or A dash, B dash, C dash, the image of ABC under axial symmetry in the x-axis. So we just got to go mirror it through the x-axis. So the x-axis, axial symmetry, down 2. So go down another 2, we get to A prime. C, we have to go down 4, go down another 4, we get to here. C prime. B, because it's on the x-axis, doesn't move, so it becomes B prime. And if we're to draw this triangle, A prime to B prime to C prime, the next part of this question asks which point is the intersection of the triangles, and you can see here point B has to be the intersection of the triangles. So put your point B in, and then the point PS lies inside the triangle, and you're given P and S, we're just told it's a real number, just to confuse you. Use this fact to write down the coordinates of a point that must lie inside the triangle A prime, B prime, C prime, and give your answer in terms of P and S. So whatever goes into this here has to be a P and an S in some form. So something that might look a little bit complicated actually is pretty straightforward. So let's have a look. If we take this point here and we call it PS, it's the point 8, 2. So let's put that point, mirror it inside the other triangle. So in terms of P and S, the point is now, it's still 8, it's minus 2 though. So 8, 2 is PS, so 8 minus 2 must be P minus S. So just in terms of, is the last part of this question, probably something not going to be answered brilliantly, but quite simple when you do it like this. Question 5, we're given a coordinate diagram at 16 points marked with a dot. You're told here what a dot is, in case you didn't know. Louise picks 1 point at random from the 16. Find the probability. So if there's 16 dots, the probability has to be, let's say, x over 16. Something's going to happen here. It's that the line has a slope greater than 1, and we're given this jargon here, the equation of a line that goes through the point she picks and 0, 0. So really, it's our knowledge of slopes. So here's a slope here, the same as this one, the same as this one, the same as this one. 1, 2, 3, 4 of the points have a slope of 1 over 1 or 2 over 2. 4 of them, the slope is equal to 1. What else have we got going on? So if she goes from here to here, it's going to be a slope of rise of 1 over run of 4. It's going to be a slope of 1 over 4. If we go to this point, there's going to be a slope of 1 over 3, and to this one, 1 over 2. 1 over 3 and 1 over 2. Let's see, can we see a pattern here? So there on the right hand side of the slope m is equal to 1. So there's 6 that have a slope that we can say are less than 1, which means on the left hand side of it there's 6. We can see the 6 dots here. These 6 dots all have a slope. 6 have a slope greater than 1, and that's what we're asked here, a slope greater than 1. There's 6 of them out of a total of 16. In part B, we're asked how many of the 16 points marked with a dot are a distance of exactly 5 units. Now this is your knowledge of Pythagoras. Any triangle where the diagonal is going to be 5, which we'll see in a minute on the diagram, we're going to have a 3 and a 4, or a 4 and a 3. So this should give you knowledge here that the points required are 3 and 4 and 4 and 3. There's no real kind of guessing with this one. You kind of either know this or you don't. So I just put them on 3 4s up here. Draw it to the origin. You can see here I've got a run of 3 and a rise of 4. So the slope here, I've got 5 on the diagonal. Slope is rise over run, 4 over 3, and then the point 4, 3 would be up here. The slope would change, but the length of the diagonal would be the same. So there's 2 points here that will give a diagonal of exactly 5. In question 6, the diagram shows this quadrilateral WXYZ, as well as its diagonals WY and XZ, as you can clearly see in the diagram. And it says, without measuring, perform constructions on the diagram to show that the diagonals bisect each other. That means it cuts them into equal portions. So it means that this length here, W to the center, will be the same as the center to Y. So to show they're the same length, we put the point of a compass on W. I don't have the compass function here, but if you measure the distance to here, you'll get this arc like this, and then you put the point of the compass here on Y, and you measure the distance, and the arcs will touch in the middle. They'll be the same shape, a little bit like this. And if I just rub them out, and then we do the same, we put the point of the compass on Z, and we measure the distance to here. It's not going to be like that, but I'm just exaggerating to show you what it should look like, and they will touch bang on here. There won't be a gap between them. That's the construction lines that they're looking for here. So part B, the diagram shows the parallelogram ABCD. Looks suspiciously like a right angle rectangle, but we'll call it a parallelogram. Its diagonals meet at the point O, and in this parallelogram, DAB is equal to ABC, DAB. So we're dealing with the triangle DAB. Look at this one in blue, DAB. Always draw them outside of the diagram. DAB, we're not to assume it's right angled. We're told DAB, this angle here, we'll call it angle 1. And then we'll do the other triangle, which is ABC, which is this direction. So here's my triangle ABC. And the angle is at B. This is the angle 1. They're equal. So if we think about these parallelograms, they've called it a parallelogram. We need to show really that it's a rectangle, because of this angle here at the bottom of this corner and this angle at the bottom of this corner are the same. They have to be 90 degrees each, because 1 degree tilt either left or right will stop it being a rectangle, and they can't be the same if they're not 90. So they're about 90. Therefore, this side, which is equal to this side, would have to be equal to this side, which is equal to this side. These two sides are equal. Therefore, we can say this angle here, I'll call it angle 2, will be equal to angle 2 in this corner here. Let's make it a bit bigger. Angle 2 and angle 2. And we can say these are the same as these guys, because opposite sides of a rectangle are equal in measure. This one will be the same as this one. This angle here will be the same as this angle here. They're vertically opposite. So as angle 2 is equal to angle 2, therefore the question that we should have come back to at the start, ABO, is isosceles.